why shouldn't we start a video with the dulcet tones of Bud barking at nothing in the background? Okay, welcome back everyone. So what we've got on the bench today, as you've probably figured out from the thumbnail, is a Courtenay 5C. It's a little cathedral set, 5 valve from probably 1932, maybe 1933. A little bit hard to tell. Radio Corp, even in these early days, were using serialization of the date codes, but I don't know that this one falls into that serialization era. Now, interestingly, if we look at the serial number on here, 2995, which would seem to indicate that this is a 1932 set, but it's only a 4-digit serial number. And what I think is that the 4-digit serial numbers were not date coded. I think it's only when they added that 5th digit that the date coding came in. So this might be 32, it might be 33, and the reason why I think it's a little bit hard to tell is because Radio Corp made a heap of sets, 5 valve, around that 1932-33 era, that all had similar model codes and similar circuitry. So if we take a look at what we've got for possible circuits here, we've got this one, which is drawing 110, so reasonably early on in the Radio Corp lineup, and this one, which is drawing 128. Now this one came from the Pacific service data for a 5 valve superhet. Pacific didn't use model numbers in these early days. This one is the Courtenay 5C schematic, but also, depending on which service data you read, possibly the model 103, which it gets a little bit murky in these early days trying to figure out what was going on. There was also a 5A and a 5B. The 5A schematic, this is the 5A schematic modified for the 5B, and the difference, I think the 5A used 24s and the 5B used 124 as a detector, but it used a 57 and a 58 in the front end. This one used 57, 58, 57, 47, apart from some which used a 59 here. Anyway, we can have a quick look here. That's an 80. You can see 247 there. The fact that the socket's marked 247 probably makes it an earlier socket, and the valve itself is a 47 because this would have been played to death, and I'm pretty sure that none of these valves will be factory original. Yeah, so this one, if we have a look at the detector, and I'm just going to take that off carefully because I don't want to rip the cap off here. So when you're pulling these caps off, you want to be careful because that cap is only glued to the glass, which means it will pop off. So these are the early valve shields that they had. Fairly simple. I don't know whether they were making their own valve shields at this point or whether these were purchased from somewhere, but they do the job. We've got an Arcturus blue valve. Which I cannot immediately see a number on, but the valve socket is marked 57. So to me it says it's one of these two, and there's not huge differences between these two. There's a bit of a difference here in the plate supply to the anode bend detector. We've just got one simple 50k resistor, 500k resistor, sorry, off the HT through the filter, the audio filter, Here there's 100k and a 250k with a capacitor to ground in the middle. I'm guessing that's just a slight improvement for noise. There's subtle differences, and they are subtle. So I'm actually against what I normally do. I'm not going to test this yet, and the reason why will become apparent in a moment. Now there's a slightly different valve shield again. If you look inside there, this one has a collar inside it. I don't know if that collar is just pressed in and it's fallen out of this, or whether they felt that the collar was necessary extra shielding for the IF, which is a 58 as per the schematic. Not really sure what the story is there. And then this one, just to maintain the ludicrous nature of the differences, is different again. Now this could be, no, don't know. Don't know which the originals are. It doesn't matter. It is what it is. It'd be nice to do a full restore on this. I'm not going to at the moment. I just want to hear it sing. And this one has 57 marked on the base, so that's right. I mean, it's marked as a 57 here. So we've got the valves out, set. It all looks reasonably original. It's horribly sticky, this stuff. I don't know if it's a rust preventative or bug spray, but that it's not pleasant. I imagine these are original TCC electrolytics, and had an interesting comment from someone the other day. Emailed me, and one of their questions was, RadioCorp made their own capacitors and a whole heap of all their own components. Why didn't they make electrolytics? Which I have no answer for. My only guess is that the engineering of the cans was considerably more complex than making normal caps, and maybe they just didn't have the tooling for it, and maybe by the time they did, it just wasn't worth their while. Companies like TCC were spitting out caps by the bucket load, and they probably weren't that expensive, so maybe they just felt it wasn't worthwhile doing. So underneath, what do we got? We've got a bit of a mess. So as you can see, there's sort of fly lead resistor there onto the volume control. Yeah, so this is why I didn't want to power it up, because we've got some really odd stuff going on in here. We've got some tag strips that were never there originally. Those are quite late model tag strips. So there's been a wee bit of repair work. Some of these, and I think it's the 5A and 5B, have a tag strip that runs through here. A flat board with tags down either edge, and all the components are laid across. And I don't think this one ever did, but there's been some sort of jiggery pokery of how the components are laid out in here. We've got some plastic wire, which is obviously not right, but you know, things have been replaced. I suspect, looking at the plastic wire coming through from the transformer here, that either this transformer is not original, or the wires were rubber and has fallen apart, so it's been replaced. Not a huge fan of it, but it's working. I suspect that one day I'm going to want to restore this set. Today is not that day. Today I want to make it sing, but there's a few things that I think I could probably do to make it more original looking underneath here when that time comes. We'll worry about that later. At the moment, let's make noise. I mean, there's a lot about this that is not original, and getting it original I think would be quite difficult. Output transformer on the speaker is also not original. The speaker has been painted silver, and a lot of the chassis has been painted silver as well. In fact, I suspect that this might have been reasonably rusty, because I can see a lot of really rough pitting in the metal under here. So I think what's happened is that at some point this has been entirely stripped, possibly sandblasted, and then repainted. And there's other evidence to suggest that. There's some silver overspray on the edge of this tag here. You can see it in around the speaker rim. There's paint on these two rivets and on this. Typically these are brass coloured. So this has had a lot of work, and there's not a lot of original left other than the sort of the core componentry, the valve sockets. And in fact, interestingly on that, these two valve sockets, the rectifier and the output bottle, are still riveted in. And you can see, no you can't, ignore that. Well, you kind of can. There's a little bit of silver overspray. I was going to say that that really oversprayed, but this one's really oversprayed, but it's screwed in. So the 57, 58, 57, those sockets are screwed in, so they've been taken out as part of the repairs. So yeah, these are fairly modern machine screws and hex nuts, not probably square nuts like it would have had, but they, you know, Radiocorp were using rivets to hold stuff in by this stage. So the fact that these are screwed in tells me that they've at least been taken out, possibly been replaced, although they do look the same style, so probably they are original. Right, alright, so I'm going to use some 10 mic 500 volt, and these are surge rated to 560 volt, which is all we'll need and more, but they are single-ended caps, so they're not going to quite fit this layout. Now that's not really a problem because this tag strip has been added, so actually I can probably stick these, since the positives are here, I can stick one from here to this earth, and the other one just needs to go wherever that orange wire goes, so I can probably poke that somewhere else, more convenient as well. To wrap it around that tag. Now, interestingly, I had somebody ask me the other day about solder and where I get my solder from. I have two rolls of solder. I've got this one, which fell off the back of the Air Force. It didn't really, it was being disposed of. This is silver solder, and it's not plumber's silver solder, and unfortunately the label's gone. But in solder you have, typically lead solder, you have a 60-40 mix of lead and solder, and that 60-40 is a general classification, but it's more often than not maybe 62-36-2 or something like that. The mixes are predominantly lead and solder, but then there'll be one other element in there which is designed to offset the different cooling rates of the metals and, you know, keep the solder intact as it's being cooled. Or at least that's my understanding. This stuff, the third element was silver, and it was what we used in the avionics bay at Hakia, and then somebody read something somewhere that said that silver solder could go brittle and crack, and because if you're soldering stuff in aircraft and it breaks, the aircraft can't pull over on the side of the road, and it can be mildly catastrophic, and so it was being thrown out. So I grabbed a roll. I wish I'd grabbed a couple of rolls because this is nearing the bottom layer now. I've used this since I was probably in my early 20s, and it's lasted me all that time. It's a 500 gram roll, so been a brilliant roll of solder. Very happy with it, and I'll probably try to find something equivalent when it does finally run out. The other roll of solder I've got, it was my dad's, and this is a Solder 5 made in Auckland by Dominion Lead Mills Limited. This stuff is pretty good as well. I notice in places that it's exploded and the flux has kind of blown out a hole in the side of the solder, but I certainly haven't had any problems with that. The size of this, I think this is about 1 mil. I think this stuff's maybe 1.2 to 1.5 mil. I wouldn't go smaller than 1 mil. You just end up feeding way too much in. I mean, weight is weight. You've still got the same amount. It's just, I think this is a wee bit nicer because you're not having to feed so much in when you're doing a solder joint. But yeah, I would not use lead-free solder in these sets. I don't use lead-free solder at all. I think it's a jip. Someone was just having a Steffi when they came up with that rule. So yeah, it's god-awful stuff. It's horrible to solder. It has a really weird, I think the term is eutectic point. Not really sure of the exact term, I just wanted to use a big word. Tin lead solder for me, all the way. If you don't like it, well, that's okay, you're allowed. So, that's that done. I'll get that. Let me think about this one, because if we take this out of here, then we've got these two wires, which I'll take out of here as well. Ooh, hot. Who knew? If I do that, we no longer need that piece of tag strip. If I can find a suitable place to mount these, alright, so those are now hooked. They can't come out, they won't come out. That's not going to touch anything. If I was really concerned about it, I'd have put some heat shrink over it, but I'm working with short wires, and that will be fine. At least if and when the day comes that this gets restored, it's still got the original caps in it, which can either be restuffed or these can just be put on tag strips on those and then wired back in the way they would have been. It's not going to make any difference to the way the set plays. It's really just it's almost a vanity thing, or maybe it's a stupidity thing, I'm not really sure. Restuffing caps is just one of those things that, it's a fun exercise, I enjoy it, but it's pointless, it's completely pointless. Serves no purpose at all. It looks nice, and it's kind of cool to try and recreate these old things. But this will work fine. Okay, so that's the electrolytics done. We've got a cap that's fallen off up here because it was just tacked on and possibly not tacked on all that well. Get in and have a look at resistor values. Alright, so what do we got here? This is 1, 0 and then 4 zeros, so that's 100k. $224k. So that is mildly high. This one, now these dog bone resistors, you read them body, end, dot. bed, so it's the bed system. Body is the first colour, the end is the second colour, and the dot is the number of zeros, or the multiplier. So green is 5, black is 0, yellow is 4. So 5, 0, and then 4 more zeros is 500k, or 500,000 ohms. And this one is 950k, almost a meg. That's almost double what it should be. You know, that is so far out as to not be funny. That one is over double what it should be. Again, brown, black, yellow. Brown is 1, black is 0, and yellow is 4. So 1, 0, 4 zeros, that's 100k, and that was reading, what, 200 and something, so 224, that's over double what it should be. So these are both over double where they should be, and that is not ideal. But actually, I'm just having a look here. These two resistors are tied together on this tag. There's nothing else off it, so where does that come from? Please hold, caller. And if we look at the, let's start with the earlier drawing. So this green wire is from the grid of the output tube, and so it goes to here, and then we've got what is probably a 0.03, so that's 0.01 to tone control. What the hell? Okay, where's my book? 47. Grid is pin 3, which is this one, which is what? So that's across the output transformer, which is going to be some kind of tone compensation. The plate does not go to the tone control. So that's interesting. The grid goes to the tone. Grid goes to, well, is this tone or volume? I expect, given that this one's over in the RF side of things, that this is our volume control, which means this should be the tone control with the on-off switch on it. Why is the tone off the grid? Is that miswired, accidentally or otherwise?
Ah!
So the grid should have either way. There should be a 500k resistor to a 0.25 to ground, and then that 500k resistor is fed from the back bias network here, and a 0.01. Our grid, which is this pin here, has the 0.01 going back to the audio filter. So if you've watched any of my other ramblings, you'll have seen this arrangement before. This takes the RF, which are the radio frequencies that are dealt with back here, and dumps them to ground. There's a pi filter that basically rejects RF, passes RF straight to ground and gets rid of it, and the audio will pass straight through this into the final output valve to be amplified. So that's these two capacitors here, these 200 pit caps, and this resistor, the 10k, and then from here we've got this 0.01 feeding onto the grid, which is correct. We've also got a resistor here, which, wow, this is all messed up. It's all messed up and I don't know why.
Ah!
That's weird. Weird. What was going on? What were they thinking? What am I going to do? Well, at this point, dear viewers, I'm going to let you decide. Oh dear, this was supposed to be, well, I mean they're all supposed to be a quick repair. They never really generally turn out that way. I didn't want to mess too much with this, but actually this is quite messed up. So what do? Do I do a quick and dirty recap, flip it over, power it up, see if it goes, call it done? Stick it in the kitchen and by the coffee machine and listen to it? Or do I strip it and rebuild it? At which point should I set it aside and actually work on the Pacific, which is staring at me from the other side of the bench accusingly? I don't know. You tell me.